8.5. Today we're going to be talking about determinants. So, what is a determinant? Let's say for a 2 by 2, where the matrix is A, B, C, D, your determinant is AD minus BC. AD comes from the first diagonal. BC is the second diagonal. So we're going to start with, from the book, problem number 9. So the matrix is half, half, 1/8, negative 3/4. When you're doing the determinant, you only need the straight lines, so AD 1/2 times negative 3/4 minus BC 1/2 times 1/8. Multiplying across, we got negative 3/8 minus 1/16, making them 16ths. We have negative 7/16. So, answer is a number. Now, what if it's a 3 by 3? Well, there's two ways to do this. And the first way is if it's A, B, C, D, E, F, G, H, I, we rewrite the first two columns on the outside. So A, D, G, B, E, H. And similar to our AD, we have a diagonal with 3 pieces. So we're going to take all 3 of our diagonals and add them together. So the first one is A, E, I plus B, F, G plus C, D, H minus, now it's like the BC, we have the 3 diagonals going the other direction. This is why we need the 2 on the outside. So first we have G, E, C plus H, F, A plus I, D, B. So, for example, let's do problem number 31 from the book. So, our matrix is 1, 1, 1, 2, 2, 2, and not what you think, negative 3, 4, negative 5. So once again, we'll take the first 2, we'll rewrite 1, 2, negative 3, 1, 2, 4. We'll take our first diagonals, like the ADs. So we have all 3. We have the 1 times 2 times negative 5, which is negative 10. 1 times 2 times negative 3 is negative 6. And 1 times 2 times 4, which is 8. Then we subtract our other diagonals. I'm going to circle all 3 so we can see them. So 1 times 2 times negative 3 is negative 6. 1 times 2 and 4 is 8. 1 times 2 and negative 5 is negative 10. So our determinant is negative 8 minus a negative 8, so it's plus 8. Our determinant is 0. So again, our answer is a number. And now for this second way. So we rewrite our original matrix, and we're going to expand it. So 1, 1, 1, 2, 2, 2, negative 3, 4, 5. So how we expand it is we take a row or column. I'm going to do this column, and it's plus, minus, plus alternating. So if I'd gone the top row, it'd be plus, minus, plus, etc. So I have a positive 1, and then we write what's left, ignoring this row and this column, which is 2, 2, 4, 5. Then the next piece is a minus, so minus the 2, and again we write what's left, ignoring this column, this row, because of the 2, 1, 1, negative 3, or 4, 5, and then plus the negative 3, ignoring this column and this row, we have 1, 1, 2, 2. And then we expand these, same as we did with our 2 by 2's, AD minus BC. So 1 times 10 minus 8 minus 2, 5 minus 4's, minus the 3, 2 minus 2. So that's 0. 5 minus 4 is 1, times the 2 becomes the negative 2, and 1 times the 10 minus 8, 2 minus 2 is 0. Again, we have the same answer. Okay, so what good are the determinants? We use them to solve. So problem number 15 from your book, 4x minus 5y equals 17, 2x plus 3y equals 3. So the matrix we set up from the variables. So the first column, 4, comes from the x, and so does 2. My y values are the negative 5 and the 3. We'll come back to these answers later, so hang on to these two. We're going to solve this now using Cramer's rule. What Cramer's rule tells us is that we use the determinant, which we call D, and then we replace x, calling that D sub x, and we'll replace y, calling it dy. If I had a z, I'd do dz. So the determinant is AD, in this case 12, minus BC, which is negative 10, minus minus. So we get 22 for our D. Now for dx, we're going to take our matrix, and this time we're going to rewrite our y's, but we're going to put the answers in for x. Again, our determinant, we're going to take the AD, which is 51, minus BC, which is negative 15. Again, minus minus. So we get 66. This is our D sub x. For our dy, we'll do the same thing, this time keeping our x and replacing y with our answers. So our determinant, AD, is 12, minus BC, which is 34, subtracting, we get negative 22. Again, this is dy. Now, what Cramer's rule allows us to do is solve for x because it's dx over d, and y is dy over d. So our dx for x is 66 from our answers, over our original d of 22 is 3, and y is the negative 22 over the 22, which gives us a negative 1. And as with all solutions, our answer is the point 3, negative 1. Now, that's for a 2 by 2. What if we have an equation with 3 variables? So again, one from your book. We're going to do x plus y plus z equals 0. 2x minus y plus z is negative 1. Negative x plus 3y minus z equals negative 8. So again, we're saving our answer column for later. Our original matrix x, y, z comes from our coefficients 1, 1, 1, 2, negative 1, 1, negative 1, 3, negative 1. So as with before, we want our D, our determinant. So we'll rewrite the first two on the outside. 1, 2, 1. Okay, so ADs are 3 diagonals. Which gives us 1 plus a negative 1 plus 6 minus our other diagonals, like our BCs, all 3 of these. So we have, and now that's a negative, we have 1 plus 3 minus 2. 6 minus 2, which gives us D of 4. Solving for our dx, we're going to take our matrix. We're going to leave our y values and our z values. Then we're going to take our answer column and we're going to substitute it in where x would be. Once again, rewrite the first 2 rows. Now it's 0, negative 1, negative 8, 1, negative 1, 3. Our ADs now have these 3 here, which give us 0 times anything is 0, minus 8, minus 3, minus our BCs are the other diagonal. Multiplying, we get 8 plus 0 plus 1. So negative 11 minus 9 gives us negative 20. Now for dy. We're going to keep our x values and our z values. We're going to replace our answer column in for y's this time. Again, we're going to rewrite our first 2. Take our ADs, all 3. Multiplying, we get 1 plus 0 times anything is 0 and negative 16 minus BCs, all 3 diagonals. Get 1 plus negative 8 plus, well, 0 times anything is 0. Don't need the 0, but we'll write it. So we get negative 15 minus negative 7, double negative. So we can write this as plus, and we get negative 8. Last but not least, we need dz. So we'll write our x's and our y's. Oh, and we need to change our z's to our answer column. So 0, negative 1, negative 8. Rewrite the first 2. Now we'll take our ADs one last time, all 3 diagonals. multiplying, we get 8 plus 1 plus 0 minus, take our BC's, all 3 diagonals, we get 0, a minus 3, and negative 16. So 9 minus negative 19, double negative, gives us 28. So x is dx over d. So 20 over 4 is 5. Y is dy over d. The negative 8 over the 4, which is negative 2, and z dz over d is 28 over 4, which is 7. Again, a point, 5, negative 2, 7. And we're done.